Another just we'll give it one more minute and then we'll get started, everybody, just to give folks a chance to join us here as we get to the top of the hour. All right, everyone, we can ease into this. I see that we have a handful of folks joining us. We got 1 o'clock. We will get started. So thank you, everybody, for jumping on this afternoon with our team. Thank you for the USIBD and the Scan2Bim University for asking this team to collaborate and present today. It is much appreciated. Today, we're going to be specifically looking at a project for the Massachusetts Port Authority, specifically at the Boston Logan International Airport, focusing around Terminal B and a Scan-to-BIM to GIS workflow. We'll start with some general introductions. I'll go first. My name is David Nachreiner. I am the Director of VDC for VDCO Tech, based out of Fort Lauderdale, Florida. I am based out of and work remotely from Buffalo, New York. I've been in VDC and BIM and design and construction technology for about 15 years, both across the United States and also throughout the Middle East. I'll turn it over to Ali next.
Thank you, David. Hi, everyone. My name is Ali Borhani, Senior VDC Project Manager here in Massport, and I'm excited to be here today and share some of our lessons learned for our great working with our consultants. Sean?
Yeah, good afternoon, everybody. Thanks for joining. My name is Sean Doyle. I'm the Director of Integrated Design. 13 years, going on 13 years of running bonds, in-house reality capture services, and been a longtime partner of working with David and Ali at Massport on various laser scanning needs and things like that. We also do work primarily out of the Boston office, but we do work kind of across the United States.
All right, thank you, Ali. Thank you, Sean. I do want to introduce two other companies that aren't specifically on this panel here this afternoon that are currently and will continue to be instrumental in our project at Massport in support of Massport's initiatives is NV5 and Brennan Consulting. So NV5 and Brennan will both come up occasionally throughout this presentation. NV5 has a good chunk of the efforts with us at Massport. They're providing laser scanning, modeling, and GIS activities currently and in the forthcoming projects. Brennan Consulting was instrumental and will continue to be instrumental in our survey operations as part of these Scan2Bim to GIS projects. Quick agenda today as we try to fill this hour time slot. So we're going to talk about a little bit about the Massport's BIM and GIS strategy, a little bit about the Terminal B scope of work that we're focusing on, how we planned and how we are actively coordinating that project, survey and scanning operations, modeling operations, how we are using a common data environment to support these initiatives, our GIS operations, and we will have an open discussion at the end. So if the folks on the line have any questions or inquiries, there'll be time for those at the end. So please use your chat feature and we will address the ones that we can towards the end of the presentation. I'll turn it over to Ali for Massport's BIM and GIS strategy.
Thank you, David. So I'd like to set the stage for our discussion today by telling everyone a little bit about our BIM and GIS strategy, the overall rules and requirements we have, the policies, the initiatives that we have to hopefully explain why we are so interested in laser scanning and reality capture, why we are doing this in Massport, and what we try to achieve by doing laser scanning. So what you can see is on this slide are some of the bullet points. These are the ongoing activities or initiatives we have and the standards that we have published for BIM, VDC, GIS, and CAD. I start with the first one, apply the model-first approach in design and construction. So we have this term model-first approach, and that means we want to use a model for design. A model should be created at the earliest stages of design, and it should be used for construction. And then at the project closeout, we want to have the information for long-term operation and maintenance of our facilities. We want to make BIM and GIS data accessible to all end users. So we want to have it shared on the cloud, ideally, and provide proper access to not only the project teams, but also the downstream users internally and externally. We want to deploy a robust document management system for all sorts of documents that needs to be shared with people. It could be design and specs, the updated GIS maps, the point clouds, everything that would be needed during a project or after the project for operation and maintenance. We also want to develop comprehensive utility network. So it's one of our active initiatives in Massport to create robust network for the gas and water utilities. Those are what we are focused on today, but we want to expand from there and ultimately have a comprehensive network of utilities and infrastructure that we have specifically in the Logan International Airport. We, as the operator of several airport and seaport facilities, one of our key goals is to improve passengers' experience, and that could, come into many different initiatives itself. So wayfinding would be one example for that when passengers are in the airport, just having the wayfinding system to easily direct them towards their gate or the amenities and facilities they want to use. Another term we have is the point of interest, and that could be related to many different things, the food services, all the facility or specific spaces that we have in an airport terminal that we can define. We can create the points and information in GIS platforms, and then we can provide it through the applications we have or make it accessible to people. One of our ultimate goal is to create a virtual campus as a single source of truth. I'm sure you're familiar with the term single source of truth, whether it's realistic or not, whether it's doable today based on the technology, and I personally think it is doable. But we want to have a virtual campus that accurately represent all the building and infrastructure that we have in airport, and we have numerous use cases once we have such 3D accurate representation. And of course, we want to facilitate design development for new project by providing accurate existing condition information. And that means we collect information during an existing project. We transfer those information. It could be geometric information, it could be asset information. We collect them, we integrate them into our system, and then at the beginning of a new project, we want to hand them over to the new project delivery team to facilitate the design development. So as you can see, for most of these goals and objectives, the prerequisite or the requirement is to have access to accurate information. And one of the ways that we can ensure that we have accurate information is through laser scanning. So it's one of the reasons that we started a laser scanning program. David, if you go to the next slide, that helps us to collect information on time and transfer or exchange that information into other formats or other platforms that we want to use the information for. So to be specific about this reality capture program that we have in Massport, the goal we have is to complete the scanning and modeling of all terminals, cargo buildings, garage facilities, and other major assets. And we're starting with the Logan Airport, but we operate other airports. Massport operates 3 airports total, and also seaport facilities. So we want to expand to those facilities and infrastructure as well. And we also want to have a term contract for on-demand, on-call laser scanning activities as well, because it's not enough to just collect information. It's not a one-time activity. We want to have accurate information, but there is a need to maintain information up to date and accurate, right? And for that, after, let's say, some TAA modification in our terminal areas or some new construction in the terminal areas, there would be a need to update all the floor plans, all the models. And for that purpose, we need to have a long-term plan and a strategy for doing laser scanning or reality capture, depending on what tools and methods we use. But we need to keep the information up to date. So related to that would be developing some workflows and guideline for standardizing our reality capture technology and methods, what piece of technology we want to use, what are the different methods, depending on the use cases. So that would kind of require defining the use cases for Massport. What are the ways that Massport would like to use laser scanning once we have them, or the models created from a laser scan or a point cloud? What are the use cases for those? And it's not just our team, but it also would be other departments, all different stakeholders that could benefit from having this access to these models. So we define the use cases. Based on that, we define processes, methods, and technology for reality capture. And that could be a TLS, terrestrial laser scan. It could be photogrammetry. Regardless of the technology or method we use, we want to see where we can find some value for doing this. So that's the reason we in DTIG, that's the name of the group that I'm a part of, and that's a stand for Digital Technologies Integration Group. We team up with many consultants, including VDCO and Bond. We are working with some other consultants, including Feldman and NV5 to create Woolpert to create the laser scan standards. And it has been a really collaboration, and I'm glad that we were able to team up for this, really pull this off. And now today we have some great examples and success story to share with all of you, and hopefully it's useful for some of you who are going through the same journey. So with that said, back to you, David, and let's talk about the specifics of this project.
Hey,
Fantastic. Thank you, Ali. Sorry,
maybe we should just set the stage real quick if I could just interject. One thing too,
absolutely.
it's
Great.
so between the two joint ventures, our joint venture and the Feldman joint venture, we have to tackle, I think it's 477 structures, right? Is the plan under this contract over those 6 or 7 facilities. So it's quite a big undertaking by Massport and quite the investment by Massport to get that virtual campus environment.
Yep, great point.
Yeah.
Yeah, thank you for that, Sean. That is a great point. Focusing specifically on this project, it's been a good effort so far. Our team, VDCO, Bond, NV5, Feldman, a few other parties, we're specifically focusing right now on Terminal B. Terminal B is made up of 2 separate buildings, Building 27 and Building 29, that comprise the entirety of the terminal. The terminal itself is approximately 1 million square feet, Ali, maybe 900 to
990.
990. Sean
990.
remembers that number well. We did a takeoff of that a couple of times.
Yeah.
Make sure our numbers aligned. This project leading up to this, we kind of broke it out into, multiple phases, right? There was a pre-mobilization phase, just trying to get all of the data collected of what we needed to do, when we needed to do it, how we needed to do it, collaboration and coordination with Massport and the project stakeholders, which we'll talk about more here in a little bit. And then the field mobilization, which was the surveying operations in coordination with the Massport on-site operations and survey control teams, laser scanning activities by Bond and ran by Bond, also in conjunction with NV5 and Brennan. Then the goal was to take those laser scans, that data, and create an LOD 200 architectural model as the baseline for capturing the existing conditions in a model format using Revit. Now, I will say this, the baseline was an LOD 200 model, and we are actively about to finish these models as we speak in the next coming weeks. But just by default, in the nature of our teams, our modeling teams, VDCO, Bond, NV5, we have a lot of content in there that is a good starting point for Massport to use that's well above that LOD 200 level. So the nice part about it, this model, is that we are doing it for a specific reason, the Scan-to-BIM to GIS initiative. But these models that our team is creating, that the Feldman team is creating, Wolpert team is creating, they're going to give Massport the baseline and be able to use these for all different activities throughout their operations at the airport, from designs to construction to renovation projects, you name it. So it won't just be for a GIS output. It will be for future use and updates throughout the life cycle of these facilities across Massport's portfolio. And then last but not least, GIS extraction. So we're going to talk about GIS today, but we are in the throes of that process now, specifically on Building 27, getting it into a GIS compatible format, and pretty soon here, Building 29, as we close out this initial work order. Ali or Sean, anything to sprinkle on top regarding just overall general project scope for Terminal B?
Nope.
I think that's a good overview.
Okay. Planning and coordination. So, VDCO is the prime on this project, and we have our project participants and collaborators along with us. And it's a big undertaking to look at a facility of this size, look at all of the specs and all the information available to us that we have to comply with, and move forward with a plan. Massport is a very, I call, a mature owner, a mature client when it comes to knowing what they want from designing construction technology. There are standards, there are specs, there's requirements. You don't always fall into that when you're working with an owner. Oftentimes we have to help develop that. But, because Massport has that depth of knowledge and that depth of information available, it's important for a team like ours to understand what exactly it is that we need to do, how we need to do it, and why, so that our deliverables align with the initiative set forth by the client, in this case, the Port Authority. The other thing that is important too is that because we have these adjacent contracts that are moving at the same time, there's a team in Terminal E, there's a team in Terminal B, forthcoming in Terminal A. We need to understand the lessons learned from the previous projects that followed the same format. We fell into this initiative as the second team in. There had already been an initiative in a previous terminal. So for our team to take those lessons learned and collaborate directly with a Feldman, with a Wolpert, whoever the other adjacent contract may be, and work with them, not necessarily compete directly with them, but to collaborate and bring them into the fold so we can work and move forward together to capture these facilities in a collective way for Massport. So understanding lessons learned from previous terminals, what went well, what didn't go well, how are they adjusting, how should we adjust fire to make sure that we're in line and that we're moving forward on the same pace. The next step was to develop a level of effort, right? How are we going to tackle this? We got to break this up into phases. So previously on the slide before, we talked about a pre-mobilization phase. What do we need to do to collect information to move forward with a mobilization phase, right? Then we have to mobilize, conduct survey operations, scanning operations, badging and on-site training requirements, right? Massport doesn't allow us just to walk right into the airport and move around freely on the secure and non-secure side. So there is a badging system that we have to go through. Sean is going to speak to that here pretty soon. On-site training requirements as we operate and maneuver around the airport to capture existing conditions with scanning and survey operations. And just in coordination with Massport, right? Who do we have to talk to at the terminal in order to link up with the correct people? Who do we have to call to get into all of the specific rooms that you have to capture in a building that's almost 1 million square feet across secure and non-secure sides, both on ramp and inside the facility? Establishing a common data environment, right? Like I said before, Massport is a very mature client. They had a ACC site set up. So working in and establishing ourselves on their ACC site to ensure that we have a one common truth, common data environment to share and collaborate on information. Establishing weekly meetings amongst our project team to coordinate activities both with Massport directly and both internal with our project participants. And I like to use this word transparency, ensuring that whatever we are doing, Massport has privy to, and they can ensure that it's in line with what they want us to do and what they need us to do. And the multi-team approach, it's difficult to approach a project like this just by one team, right? So we need a Bond, we need an MV5, we need a Brennan, we need these project participants to help us move forward so we can move forward together in a multi-team approach to better the products that we are providing to Massport. Before we move on, anything, Sean or Ali, to sprinkle on top of the planning and coordination?
No, I think we're gonna get right into that, aren't we?
Sean, sounds like you're up, Sean.
Sounds like I'm up. Yeah, so as David mentioned, obviously there's incredibly unique challenges to working in these environments. The Terminal B space that we worked on is actually technically two piers. When you break it down, there's over 40 tenants, seven different airlines. The cleaning crews that have access to different spaces and different closets are different based on the tenant. It is quite a little bit of a logistical nightmare, just to be dead honest, in terms of trying to kind of plan this out. And one of the big lessons learned from the first phase, which was Terminal C, that the other joint venture did, was sort of it was very challenging, very frustrating for that team to get access to some of these spaces. And Terminal C only has really one airline. But when you get into the retail and you get into the marketplace and you get to some of these other tenants, the Chick-fil-A's and the Starbucks and all these other things, key sets could be different from airline to airline. Key sets could be different from marketplace versus building maintenance. Really what was important to us, or was, suggested to us as a lesson learned from the previous venture was to do an exploratory phase. So we spent 7 days walking around with a resident engineer to go and identify as much as possible the tenant, the point of contact, or even the key, if we did or did not have it, to try to gain access to every space. It's important. We didn't talk about this in the scoping, but Massport's charter to us was to put a laser scanner in literally every single room across that 990,000 square feet. And that's true with every building that we'll do as part of this sort of global term contract that Ali mentioned earlier. So for us, we spent 7 field days literally actually getting into every room. Ironically, it would have been great to have just scanned it while you were standing in a closet, etc. But of course, you have accuracies that you need to maintain and all those other things. But in that 7 day stretch, we effectively got access to about 95% of the spaces. And Massport's a very, very robust client. It's a massive campus. They have locksmiths, they have maintenance people. There's a lot of people. There's a lot of moving operations folks. There's a lot of it employs tens of thousands of employees a day. Not surprisingly, there were spaces that we were unable to identify who's renting this closet, who's renting this office, who has the keys to this. And so that exploratory effort was very, very, very valuable to us to identify, okay, if we're going to tackle this in a quick and an efficient manner, then we need to make sure we know who to call, who to contact, let them know what time we're coming, arrange as much as we could a continuous data capture process to help maintain accuracy and help maintain, the right level of detail. So you can go ahead to the next slide, David. Once we completed that process, once we had sort of done the site walk and we had identified all the tenants and clients and keys and access and phone numbers, we worked with my team is not licensed land surveyors. Massport has a pretty extensive network of their own survey control. So Ali mentioned he's part of the DTIG group. Massport has their own survey unit as well that set up and maintain a campus control network across all of their facilities. So in a lot of cases, they'll provide, survey control and monuments all around the apron, around the ramp, and the areas around the terminal, outside on the public side and the roadways and sidewalks. They'll maintain those and have a pretty extensive campus network that they keep track of. We worked with Brennan Consulting here to help us take the Massport control, which is sort of along the ring roads and some of the areas around the terminal, or the roadways in front of the terminal, and bring those into the terminal in order for us to do the control. So I'll have David move to the next slide here. Massport established laser scanning standards, quite some time ago. I think we did the original release together, Lee, in 2019. Us and Feldman and some other folks released a laser scanning standard. Ironically, at that time, SLAM was both literally a four-letter word and actually a four-letter word, in which SLAM scanning was really not sort of a preferred way for data capture in the Massport environment. So when we actually got brought on for this contract, we were very relieved to kind of hear that with proper planning, proper control, we had moved away from a terrestrial-only environment and created, we worked with Massport, we worked with the other joint venture to be able to establish basically an acceptable way in which we could combine both traditional survey control, terrestrial laser scanning, and SLAM scanning. in order to capture the square footage. I mean, to put a TLS in every single room across 990,000 square feet would have taken months and months and months of time. Basically, what happened here through proper planning and execution and identifying all those tenants was basically two mobilizations of our laser scanning efforts. So while apologize. While Brennan was doing survey control for us around the terminal and bringing some of those control points from Massport control in, we had mobilized effectively a 2 week, 3 night terrestrial spine, I will call it, through the terminal space. So if you're looking at that image there on the right, you can kind of see where Brennan is bringing in control from other areas around the terminal. They're bringing it into the exterior. They're bringing it into the baggage claim areas, the baggage handling areas. They're bringing it upstairs into the check-in counters. They're moving all of the control from Massport into the terminal for us and gives us a place to start doing terrestrial scanning. So over a 6-day period, our team ran about 1,200 terrestrial setups, basically not with the intent of actually capturing usable data for scanning, I'm sorry, for modeling, but actually in ways to set control for the SLAM scanner. So the way that works is you'll see numbered squares there on that image on the right. We basically effectively worked through main thoroughfares of the terminal, both on the secure side and on the side, side of being the secure side post security, in which we then placed checkerboard targets and things like that in monuments throughout the terminal that we were then able to go back and capture with the SLAM scanner. So what could have been 2 months of terrestrial scanning to connect every space, we really actually just created a backbone in which we knew we had sort of the 1/4 inch accuracy checked against the Massport survey control, brought into the terminal, distributed throughout the terminal. We were able to do that over 3 nights, over 2 weeks, and in about 1,200 setups. Once we registered all that data together, when we remobilized to do the SLAM scanning, because we had done such a great job in coordination with Massport and the resident engineers and all the planning with all the tenants and the terminal managers and all this other stuff, we were substantially complete within 5 nights with all the SLAM scanning. So 990,000 square feet over 5 nights. I'll be honest, like we got 95% of what we needed. There were still some spaces that we weren't able to access in a timely manner that we had to go back, but pretty much every space had been scanned over the course of the 5 nights. And so that was 2 units from our team using a Naviz VLX and then 1 unit from NV5. The proper planning and the execution, it was very easy to just line up access, have the sets of keys that we needed, have the phone numbers that we needed to be able to access. Once sort of all the walkthroughs and the terrestrial backbone was in place over that sort of 3 week period, we were able to show up and basically in a week and a half, get to substantially complete on the laser scanning. And then we only had to go back really for maybe 1 or 2 days to pick up this random closet here or this random IT room here or this storage closet over there. But by and large, I'd captured almost all of the spaces. So just some field photos. So what I'll do here is I'll show just some examples. So this is obviously us in the field. So we ran the terrestrial scanners as mentioned, basically through all the corridor spaces, through the hold areas, in the main corridors, up and down every staircase, basically to connect every level, to connect every space, to connect secure side to backside. And then once we had done that traverse and we had set all of our SLAM targets, it was very easy to just basically go back and walk both the interiors, the exteriors, the roofs. We did the bulk of the heavy lifting with the SLAM scanner and added anywhere where we needed just that extra little bit of accuracy or targeting from the terrestrial, basically to create sort of a hybrid blend. We happen to use the Faro system as our terrestrial. We've been married to that system for quite some time. So in that case, we were running 4 Faro scanners to run terrestrial spine. And then, like I said, we had 3 VLX units in order to do the bulk of the SLAM scanning. So we'll just flip through here. You can kind of see the data output that came from that. We were able to get that 1/4 inch accuracy, and everything has to be submitted to Massport in terms of registration reports and survey control, anything that was added, all the data collector reporting and all that stuff. But I think the result you'll see here is a very impressive amount of data to be captured in a couple of weeks. So To be able to hand really good colorized data, which would have taken months and months and months and months for us to capture with a terrestrial, to be able to just walk through the terminal at night after sort of the last flight would leave for the day. We were able to capture some really, really great, very accurate 3D colorized point cloud data that started our modeling effort. So, really cool process. I think if I could just put a bow on it, David, I think the biggest and most important thing we did in that process, even though it was weird to not just scan the room while you're standing in it, to be able to plan that and sequence that and have all the right information, it really enabled a really good process for us to deliver the work.
I agree. I think the site exploration phase was a necessity. I know that in the past on different projects, depending on the scope, it is easy as you're doing the walkthrough to pop the scanner in and keep going. But because we were taking a survey control backbone with the TLS VLX approach, we didn't necessarily have that. So that time was available to us to explore the airport, explore the terminal, explore what areas we could get into, what areas we were having trouble getting into, and that certainly saved us from having to go back repeated times, more than just a couple here and there because we couldn't get the key sets occasionally.
Yeah, just to put an idea on the timeline. So we had done the 6 days or 7 days worth of site walking basically in the 2 weeks leading up to Christmas. Like I was at the airport finishing the site walk on Christmas Eve, with the folks from Kevel and Massport to kind of do that stuff. We mobilized I think the day after New Year's Day because Massport did not want us on site during the travel period. It's too busy, which makes total sense. We were completed with the data into modeling. I'm sorry, we were completed with all the field work by the end of January and into modeling by the second week of February. So basically a 6 week turnaround to walk, scan, and convert and process that data and get it into modeling. So the proper planning definitely helped us out there hugely, immensely.
You bring up a good point about holidays and operating just in an airport and the busy season. Sean, can you briefly speak to just, the schedule of which we scan, nighttime in and around holidays, operating in an airport that is occupied by hundreds of thousands of people every week?
Yeah, I think what I'll do is I'll actually give a compliment to Massport here, right? The way that they work with their tenants, the relationships that they share with their airlines and their tenants, the way that the terminal managers are engaged with the everyday users, both from a customer experience standpoint, but also from an operation standpoint. Everybody we kind of came across was generally aware, we had all kinds of work order, work plans and advisories and things like that that would get submitted week over week in the areas that we were working in. And we would touch briefly with the terminal manager each week when we arrived to kind of talk about any tricky situations so that she could be impactful in that process. But because Massport forever has been a long time adopter rather of the laser scanning process, of the survey process, the way that they handle 3D modeling and BIM, and the way that it's integrated into their workflows. Generally, everybody we came across was somewhat aware of what we were doing and why we were there to do it. So any of I'll call them back of house spaces. So not baggage claim, but baggage handling areas, sort of under the lower floors that the general public never sees, any of the exterior work or ramps, the rooftops, any of those spaces that were not really customer facing, we actually did during normal daytime hours. And then, so basically we would do 1 week of regular first shift hours to capture back of house spaces, run traverse through baggage handling areas, etc. And then anything that had a public facing, so your concourse, your gate hold areas, baggage claim areas, check-in counters, we would do those at night. So basically, the reason why there's sort of a 3 days here, 3 days there is we basically would switch between nights and days, week over week, and just capture which spaces needed to be sort of off hours as things would be closed up. So we would run basically a 7 to 4 shift to capture most of the stuff that was back of house during the day, and then the next week we'd come back and we'd work like an 8 to 2 a.m. shift, and knock out a lot of those public spaces that the general public have access to.
Perfect. Thank you for that,
Sean,
Sean. Ali, anything to add before we move on?
Yeah, I would like to add one good thing. As Sean mentioned, we have been doing this for quite some time. So we have developed some procedure over time for specifically laser scanning, knowing what the stakeholders we have to notify for this, to be all on the same page in terms of the tenant knowing that their space going to be scanned from, what point to what point, what's the start and end date of that, how the space and how that terminal area would be impacted, so we can notify all the operation team and all the other stakeholders that needs to be know about these processes. So there are a lot of work that happening behind the scene to make this process more seamless.
Yeah, one thing too that we actually didn't mention too is right, like this is such a secure environment, right? You have the Mass State Police, which provide the security there at the airport. Uh, just the training and the heightened sensitivity that everybody has who works at the airport when it comes to, you can't leave the case just laying out in the middle of the gate hold area for the laser scanner. So it's very important that it was very important for us and as Ali mentioned here to make sure we're coordinating with TSA, to make sure we're coordinating with the Mass State Police. Like we're including photos of all the, like when the advisory would go out, include photos of all the equipment, all the targets, all the tripods, basically as an identifier to say, hey, like you will see these things scattered throughout the area. And it's critically important too to make sure that you're never too far away from those things. You don't set up an area and then you go take lunch. Like we were very careful to make sure that we'd finish an area, demobilize basically whichever area we were working in, and then set it back up after lunch because it's just not something you want to leave kind of hanging around. So
Yeah.
a very interesting process and one that it's one that's been well established by Massport for a long time, and so it's good that we all can operate in that environment.
Yeah. Absolutely. Thank you both for that. Those are great insights on that. We'll move into the modeling operations phase of the project. So I like to call it the coloring in between the lines after all that field work occurs. We took an approach to this where we had 3 teams across 3 companies, and about 8 to 10 modelers at any given time in the file. So the 3 main companies that were conducting modeling operations were VDCO Tech, Bond, and NV5. And it's really difficult to coordinate that many modelers, that many folks just within one company, but across 3 teams, we really wanted to approach this modeling effort in a collaborative, organized fashion. So the first thing that we did was we created a modeling plan. Who was going to do what when, and kind of an introduction into how we're going to model, what we're going to model, who's going to model what, kind of a internal BIM execution plan that's based and founded in Massport standards and what the initiative was and the goal of the modeling operations were, so that we could move forward across 3 teams in an organized fashion. Using Massport's Autodesk Construction Cloud as our common data environment, we were able to publish and locate all of our models up on ACC. We created 2 separate models, one for Building 27 and one for Building 29 that made up Terminal B. It was important that those models be separated and operated internally in separate fashions. So we started with Building 27 and then we moved into Building 28, and that modeling effort was staggered alongside of the registration of the scan data, right? So scan data would be available for 27, we would start modeling 27, and then we're moving into 29 as that data becomes available. Establishing the modeling plan to organize the efforts was the first starting point to make sure that all of the team was able to see what they were going to be doing, when they were going to be doing it, and how they were going to be doing it. We established a modeling schedule. We broke it up by building system, in a sense: exterior shell, slab on grade, interior walls and partitions, rooms, plumbing fixtures, fixed equipment like baggage handling equipment, or kiosks at the check-in counters. And we divided that up by team, right? And we try to stagger it so that, hey, Bond's modeling the exterior shell, right? Then NV5 is going to follow with the slab on grade, slab on deck. Then VDCO is going to follow in with the interior fit out with walls and floors and ceilings, and then forthcoming with the rooms and prep for GIS. We still conduct weekly coordination meetings to look and review the model, track development, ensure that we're coordinating with adjacent terminals, which is an important aspect of this exercise. Because Terminal C had already been completed prior to our beginning Terminal B, we wanted to make sure that those models aligned with the initiatives from the Feldman and the Woolpert team, as Massport takes this model first, campus-wide model approach when it comes to specifically the terminal and their other campuses. And then one of the last main things of our modeling operation that we're focusing on is grid line establishment, right? So I'm sure that everybody on this call can appreciate in a bigger facility, an airport, an industrial facility, a manufacturing facility, you may have multiple models throughout multiple projects over the past 10 years. And each of those models may have its own grid system, right? Grid line system. So part of this modeling initiative is to establish a single grid line system that was developed by Feldman in conjunction with Massport that we are following as far as a numbering and naming convention of those grids, so that we can have a baseline for these buildings of where those grid lines are based upon what we can see in the scan data as we model. Oops. It was important that we establish and set the model up on a control system. So Mott McDonald, in conjunction with Massport, established a campus control model guidelines. Massport has a campus control model that we needed to ensure was linked into our model, coordinates were acquired, and that we aligned our point clouds to that campus control model as it relates to the guidelines that Mott McDonald had created. So as a team, Bond, NV5, VDCO sat down in Boston, and we literally set these models up together to ensure that we were compliant with this campus control model, the campus control model guidelines, this document here, before we started any modeling, right? So just to ensure that we were in line and the models were in the correct locations and the scan data was in the correct locations. And a couple of images like we were showing on the scan side, I think that from a quality control perspective, when you have three different companies, 8 to 10, sometimes more different modelers in the file at once, it's sometimes difficult to get your arms around quality control, making sure that everybody's modeling the same way that they're supposed to as they move through these facilities. We took an approach with that modeling plan to divvy up tasks so that there was no duplication of efforts as it pertained to any one scope. And as we met weekly and as we collaborated weekly and held meetings, even sometimes multiple times throughout the week, we were able to QA/QC and monitor the evolution of these models and catch things and catch issues throughout the duration of our modeling efforts. Now, we're still going to have a submission period where Massport's going to go through and QA/QC these, and I'm sure there's going to be some things that we miss in 1 million square feet of airport facilities. But because we had such a unique approach and an organized approach, those issues were captured and caught as we were modeling and going through. And we have a model that has a consistency to it that meets the project guidelines. A little bit about common data environment. So, I'm sure everybody on this call uses something, Procore, ACC, whatever it may be, BIM 360, if you're still in BIM 360. I think that this setup was imperative to our success, right? Massport established an ACC workflow. We worked on Massport's ACC. We didn't bridge our models to ACC. Our models lived live on Massport's ACC. At the end of the day, the documentation, the models, the scan data, everything we do, the meeting minutes that we produce at the end of each call belong to Massport. So we took an approach that there's no reason to bridge a model or not share what we're talking about or not bring Massport into every conversation we were having on a weekly basis. So ACC allowed us to take all that data and put it up there on a daily or weekly basis to share with Massport. So they had that transparency to see what we were doing, when we were doing it, and what stage of the process we are in. It also allowed us to use the issues and coordination features space of ACC, where we were able to, QA/QC as we modeled. Hey, you're modeling walls, floors, and doors, but there's something going on with the exterior shell or the columns. You can pop an issue real quick and put it up to ACC. And during our weekly meetings, we would address those and work through those together. The neat feature that I found as a great success is we were able to link the RCS files, the point cloud data from the VLX data from ACC into Revit, because we had three different companies. We sat down and said, well, how do we link all the point clouds together and we don't start stealing the file path when we're syncing our models, and people are losing the ability to see the point cloud data in their files. So we, with the help of Bond and NV5, we developed or discovered a way to be able to link the RCS files directly in ACC, adjust the file path settings in Revit to ensure that we could use ACC to link our CS files into Revit across all three teams. And for the most part, minus a few little hiccups here and there, it was a great success. And it saved us from having to do a couple of other workflows that we were happy we didn't have to do.
Just gotta make sure those point clouds are pinned.
Yes, make sure the point clouds are pinned. Sometimes we move them on accident.
Yeah, if I got one more email.
Just a couple other features on common data environments. So definitely ACC was our single source of truth for all information and sharing, and it still is today as we actively are working on Terminal B. But we also established smart sheets. This was mostly in the beginning. We set up this on the VDCO Tech end just to get a dashboard of who was who's doing what. A list of project links to access information quickly, so you're not searching for it in emails, and just kind of a single area where our schedule was, where our work plans could be, that we could share with the team and they could access appropriately. Navis Ivion. Sean, do you want to briefly discuss how we used Ivion before we move on?
Yeah, sure, and especially because I see actually quite a few questions in the chat about this process. So as sort of like you said, an extension of the CDE. So, there's something like 3,500 panos that were taken as part of this process. I mean, I don't know the exact room count, David, but we've got to be pretty close to 1,000 rooms across the whole building.
Really?
And so, across a 10-person modeling team, as far south as Florida, as far west as, the Midwest, and as, here in Boston with my team, a great platform for us to share the point cloud data. I know that my team has even used some of the functionality of that to section down some of the point cloud and stuff like that in smaller areas and be able to work with smaller digestible chunks. So,
Yeah.
for us, we did quite a lot of work here to kind of set up the buildings, make this usable, make it shareable. And I think the greatest thing here is that Massport will continue to have access to that for the foreseeable future, as well as they need to for remote access, right? A lot of Massport's people work at the LOC on campus, but some don't. Some are remote, some can't access, sometimes if you want to look in a room, it's a tough situation. You have to drive all the way over or get the bus all the way over, whatever. So to be able to physically actually occupy every room in the digital environment, heavily password protected, of course, I think was a great tool.
Perfect. Absolutely, I agree. Thank you, Sean. We'll address some of those questions here at the end if we have
Yeah.
time. Um, let's move on to GIS operations. Ali, I'm going to turn this back over to you for the last 5 to 10 minutes of our presentation before we come to a close. So I'll turn it back to you, and we'll go with the GIS.
Awesome. Thank you, David. And I'll try to be quick to have more time for Q&A. We're getting a lot of questions, which is great. So GIS operations, once we have the laser scan and the model, we have established some workflows for what we're going to do with the information that we receive from consultants, right? And BOMO standards is just one of them that we use for defining the rooms and room boundaries. So we do that in BIM tools, but also in GIS. And we have many different use cases for that, being using the boundaries for space planning and lease management, or also in coordination with that would be calculating the square footage and volume, right? For that, we need to model some masses for volume calculation specifically, but we use those numbers also for, energy management and energy optimization, or carbon footprint tracking. So there are many different use cases what we have the information, and we're really collaborating internally and externally with our consultants to get the information and get them with the format that we can use them easily for the end users. Related to that would be also room numbering. That's one of the things that we have a team for keeping all the spaces, room numbers up to date. Once we receive new information, it should be easily integrated into our existing database. We use FME Workbench. I'm going to talk about that in the next slides quickly. And GIS deliverable, again, once we have the model in BIM, we use certain workflows to push certain information. So it should be QC'd. We should choose what information we want to extract from BIM, but then we're going to push them into our Esri file geodatabases as well. Let's go to the next one. So some of the workflow that I just mentioned entail creating some crosswalk tables for decide what information should be exchanged and how we're going to exchange that. So we have BIM to GIS workflow, GIS to CAD, and CAD to GIS as well. And for many of these, we use FME Workbench. It's a tool, it's an Esri tool. I think it's a feature within the ArcGIS. So we use that to convert data to GIS, and for that, a prerequisite for that would be to decide what BIM parameters and object information should be translated to what GIS attribution or to what CAD layers. So all of that list should be predefined before we use FME for any information exchange. And we also migrate attribution data to populate GIS attribute for the field users. So referring to what I said earlier, the model first approach, we use model and the BIM deliverables as the single source for feeding into GIS or any other platforms across our technology stack. But model is the one that will be QC'd also for the asset information, whether we get it inside the model or outside the model as a Kobe sheet or any data schema that we use for that. We have already data requirements that we share with the teams to know what information should be delivered to us, what are the attribution related to the data types that we receive, and what is the specific format for getting the data that enables us for information exchange. Let's go to next one. So yeah, more information about BOMA standards. Like I said, it's enabled by the use cases that we define, the way that we want to determine a space or space types within an airport terminal, and what are the use cases for the information that we collect for each type of zone or a space type. But I would say the ultimate goal here is to know about our data requirements and be able to receive information on time and transform the information into CAD and GIS platforms to support the downstream users and use cases.
I do want to add one thing to that, Ali, that we are actively doing this as we speak on this project. NV5, our project partner, has been doing a great job adding this information to the model, coordinating with adjacent contracts from previous teams, and making sure that we are in line with the space types, the areas, the room boundaries, the metadata that we are putting in here in preparation for the GIS. So that activity is currently ongoing and going very well.
Yep. Thank you, David. All right, we got about 10 minutes and a lot of questions, so let's jump into Q&A.
All right, so what we'll do here, as Ali alluded to, we got about 9-10 minutes. I apologize in advance if we don't get to everybody's question. But Sean, do you want to read off maybe the first one we have on that list, and we can go from there?
I think we answered a couple of these, so I might cherry pick some, David. How's that?
Okay.
And we'll start with Ali. Carrie asked, I'm curious about your cybersecurity strategy with these goals for making this data available. It's a great question.
That's a great question. Thank you, Kerry. So it depends on the type of data, but yeah, we have certain procedure and we work actively with our cybersecurity team as part of the IT department. We work with them to know what data we can and can't host on the cloud. And also we can share, and we have certain procedure for rule-based data accessibility and role-based data accessibility, right? So the rule-based would be the type of file that we can have on the cloud and share with other users, what elements once we have the model, what elements could be shared, and there are certain areas of the airport that is confidential. There are certain type of data that we consider confidential or sensitive type of information. So we have different terminologies for different types of data that's coming directly from cybersecurity, and we just follow their direction and regulations for that. And then we have the role-based data on our ACC or common data environment that we choose what information going to be shared with what kind of users. So there are some internal users that have certain level of accessibility, and then we have consultant and external users with different level of accessibility to the data that we share on the cloud.
Okay, thank you, Ali. Sean, what we got next?
So I'll jump in here. This is more for me. There's a lot of questions in here regarding the survey control process. So I'll just maybe give like a 2-minute little byline on that. So a lot of questions about permanent control, what's inside, what's outside. So Massport maintains all of their control external to the facilities. So out on the ramp, on the apron, around the ring road, out in the roadways, etc. I mentioned the customer experience piece. Everything that we do on the inside from a control standpoint has to be very low profile or temporary. So in a lot of cases, on any project, we work with Massport to identify nearest control to whatever area we're working in, bring that inside the building in sort of a temporary way. In this case, we used adhesive checkerboards and some interior targeting that the surveyor Brennan shot in for us. And then basically completed the project over that 3-week time frame, went back and pulled it all down. So Massport may have some benchmarks and some back of house spaces or some monuments and things like that in baggage claim areas, but only in areas that are not public facing. Everywhere else, generally speaking, it's temporary control, or small little drill holes or punch holes, in some small like intersections of tiles or things like that that don't leave any kind of permanent mark. I'll take another question from Carrie here, and I'll let you answer this, David. How do you guys deal with the data sizes? We're
That's
about what? We're 160 terabyte gigabytes worth of data.
We're all of the terabytes and gigabytes of
Yeah, that's
data.
right. Yeah.
Great question. I think I'll try my best to answer this in a couple of parts, and I think it relates to the management approach we took to the scan data itself. Um, so ACC allowed us to publish the models up there. We didn't have many links. The models got bigger once we started linking building 27 into 29 and vice versa. The campus control model in, the parking ramp model in for alignment. Any models that we linked in that we needed, building, Terminal C models, we put on work sets and we could keep those closed when we didn't need them to keep the file size down. When it came to the laser scan data, Bond, NV5, and VDCO Tech sat down and decided to break up the scan data, the VLX data specifically, into zones, right? So we took building 27, building 29 of Terminal B, and we broke them up into zones 1 through 8, and then into building 29, zones 9 through 11. And we were able to export, Sean was able to, and his team were able to export that scan data based upon those vertical zones from the arrivals level all the way up to level 3 or 4, depending on the vertical circulation of that part of the building. And then we matched our work sets in Revit to align with point cloud zone 1, zone 2, zone 3. So if there was a team member or team members working in a certain area in the Revit model, they were able to close those work sets and keep the file size manageable and workable. And as far as I know, we have not had any real crashing issues in Revit on the Revit side because of our
I'm
approach.
not aware of any.
Yeah, I don't know if there's any. If
Yeah.
there were any, no one said anything. So I hope I answered that question appropriately. I think we
Yeah,
probably got time for one more question and then we'll close.
I'll just add to that briefly, David. So just to give folks a sense of what we were up against. So the VLX, I'm sorry, the SLAM data from NavVis is comprised of about 90 different data sets. And so some of them span multiple floors. So basically, we found that the best way to attack this process instead of trying to break it up floor by floor is basically have people work in zones of grid intersections, basically. So when we compiled all the data and we broke it down, we brought it into recap, and we sectioned it up, we cleaned it up, we scrubbed it, we deleted any bad points. It was easier to just grab chunks and then just export that out. Maybe I'll let you both answer this question. So there's a couple questions in here about ACC in terms of point cloud usage and design collaboration and modeling collaboration. Maybe we'll start with Ali and sort of why Massport wants to work as in ACC as their CDE. And then David,
I,
maybe you can put a bow on the
yeah,
webinar here with our process.
I will say this, we probably got about a minute apiece before we hit our mark at 2. So Ali, I'll
Yeah.
turn it over to you.
All right, I'll try to answer in a minute.
Hmm.
So ACC is basically our common data environment that we use it for many different purposes. Of course, we wanted to use point cloud because it's one of our BIM deliverables, and we wanted to use ACC to host and share that type of data as well. Now, with that said, we actually had some issues with ACC because of the size of the models or the point clouds, as we mentioned. For the QA/QC, for example, we ended up using Navisworks instead of design collaboration, if that was part of the questions you had. So we used Navisworks because of the issues that we had with the size of the file and to use them on the cloud. Since then, we have been working with Autodesk to find the root cause, and we have been uh, able to find some solution that we're currently seeking and trying to apply. But yeah, size definitely was a challenge. But ACC just works fine for hosting the information, and once we can address the root cause, hopefully would be the right tool for sharing information with others as well. All right, that's all I could say in 1 minute. Much more stuff to
I
discuss.
see
No, that was
158.
perfect,
David, back
Ali.
to you.
My
That was
phone is
perfect.
158, David. I think you got 30 seconds more.
Um, All right, one more question, and
No,
I'll
no,
take
go
it.
ahead. Yeah, I think maybe you should. I mean,
No,
you're the ACC wizard, so
yeah, I think that ACC was answered, solved a lot of problems that didn't exist, and otherwise they would have existed if we didn't have it on a project this size. From a file sharing standpoint, from a collaboration standpoint, um, from an organizational standpoint, being able to use the issues feature, being able to set up model coordination spaces within ACC, being able to pull and create an NWF through the coordination tab in
yeah,
Navisworks tied into ACC. That was a big thing for us, especially on the QAQ site, QAQC side, and still actively is. So I think that the use of ACC has streamlined our efforts. And again, because Massport is a mature client, mature owner, the framework was already there for us to just fall into. Okay. If we didn't get to all the questions, I apologize. I do appreciate them. I do appreciate everybody's time. Sean or Ali, anything before I close us out?
I would just say that we should have a record of this question, so we're definitely gonna get back to people who asked the question after the meeting. But I wanna say thank you for the time, and I'd like to thank you, David and Sean, and all other consultants that we have been working over the past year or more to really pull off this work and make this a great success. Thank you all.
Thank you, Ali. Sean?
yeah. I'll just add. I think we've talked about it. We maybe beat a dead horse on this a little bit, but I think this is a phenomenal project. I think this is something that not just our scope here, but this entire undertaking by Massport, something that'll be uh, a case study for big infrastructure transportation projects for a long time coming. And so to be a part of that and to work with you, David, and the folks at Massport and Steve and Mark and all those other guys and even the other joint venture, I think this is really good for our industry. So happy to be a part of it.
Thank you both. Yeah, absolutely. I thank you both. Thank you, Massport, Bond, and V5, Brennan, all of our other project parties and partners and adjacent contracts. I also thank USIBD for having us